All right, welcome everybody. We're here to talk about teaching Ruby to count. So counting, looping, and series are a core part of building software. During this talk, I'm going to collectively refer to these under the general idea of counting. But there's sort of two basic things that we do in software. We loop and we branch. And if you were at the coffee machine talk earlier this morning, they went deep into how to nicely work with conditionals. And this afternoon, we're going to look at working with loops. And the traditional way to count in programming languages is to use a for loop. Back when I was a very young programmer, I learned to code using a language called PHP. Now, if Andy's in the room, you might want to look away. The next few slides are not going to be for you. But when I was first learning to code, this is how I was taught to repeat things. So if I want to do something 3 times in PHP, I would say this for loop right here. I initialize a variable I to be 0, and then keep looping while I is less than 3. And at the end of each loop, increment I to one number higher. Now, there's a few ways that this could go wrong. If I initialize I to the wrong value, if I maybe don't do quite the right check, maybe I'm checking if I is less than or equal to 3 rather than just less than, I could easily have some kind of off by 1 error. And let me tell you, junior programmer Joël made that mistake multiple times. Another common thing that we need to do in programming is to iterate over an array. And this is how you might do it in PHP. So it's similar to before, but now we have another variable. We have this array. And as we're looping through, we are going to use our counter variable I to index into the array. Now this works, but again, is an easy place for a junior programmer to make mistakes. Indexing into arrays, it's easy to make an off by 1 error because array indexing starts at 0, and we often think of counting starting from 1. Again, I've made that mistake. And here's something a little bit more complicated, trying to filter an array. So this is similar to our earlier code where we're looping over the array, but now we have a third variable. We have a result array, and anytime we see a value that is divisible by 2, we append to it. There's a lot of mechanics going on in here, a lot of variables that are exposed, and it's not the easiest to read, and it's definitely a lot of room to make mistakes. Sometime later, I got into another language called Ruby. Some of you may have heard of it. And then here's how Ruby does these types of tasks. So when you iterate 3 times, you just say 3.times and a block and do the thing you want to do. If you want to iterate over an array, you say array.each, and it gives you a block, gives you the item, and you can do whatever you want with that item. Notice that there are no counters here, no indexing into arrays, no opportunities to mess up. And here's how we might filter an array. Again, we call the select method, we have a block, we have access to the value, but there is no accumulator, no indexing, no counters, no room for mistakes. And for junior programmer Joël, this was delightful. And part of the reason it's so delightful is because building delight is core to Ruby's design. It's made to be a language that is pleasant for programmers to use. And beyond that, as a Ruby community, we care about delight for our users, for our colleagues, for ourselves, for people who interact with our code. We want to write delightful code. Now, part of the reason that Ruby is so delightful to use when we're iterating is that Ruby knows how to count. Its arrays know how to iterate themselves. Its integers know how to do something n number of times. It's built into the language. But beyond just arrays and numbers, Ruby has some other really cool features that make it nice to count with. And I'm going to start with ranges. So a range looks kind of like this. You can read this as the number, as the range 5 up to 7. And a range, you can think of it as a series. And sometimes we want a series of data because we want to generate some values that we're going to use for something. But another common use for series is to be a plan for iteration. We have some sort of series, and then we want to iterate through it, and that is how we're going to control the way we do our iteration. And again, Ruby is absolutely delightful. Here's how you iterate an arbitrary range. You say 5 to 7 for each, and then you have a block, and you might output the number. So 5, 6, 7. Now let's look at something a little bit more complex. Let's say that we have a task. We need to build a series of reports. We want to build a report for every month from March to September of 2022. And we might attempt something like this. So we create a date instance for March, a date instance for September, put them in a range, and try to iterate over them. Remember, oftentimes creating a range is a nice way to control our iteration. And that works, except we're not iterating over months. We have March 1st, March 2nd, March 3rd. Not exactly what we're looking for. Okay, so maybe we need to filter down the set first, because our initial series wasn't quite what we wanted. So first we're going to select only the days that are the first of the month, and then we iterate over them. So now we've got March 1st, April 1st, May 1st, and so on. It works, depending on the task that we need to do, but we've lost a little bit of that delight. And our core problem here is that date objects represent days, not months. And so oftentimes, when you have a problem that's clunky to work with, it's because your underlying building blocks, your primitives, don't model the work you're actually trying to do. And so instead of trying to force a month problem to fit into a date size container, maybe we can introduce a custom object. So we might create a custom month object that looks like this. It's a wrapper around a simple counter, number of months since an arbitrary point. It might be the year 0, it might be something else. This is a traditional way that date and time is modeled. We don't have time to go into why that is right now, but if you want to talk to me afterwards, come see me. I love talking about this stuff. And again, because we care about delight, we don't want our users to have to create something that's 55 months or 5,000 months. So we're going to create a constructor that allows us to give it a year, give it some months, and it will do all the math for the counter for us. And now we try to build our range again. So we have our custom month for March and our custom month for September, put them in a range, and oh, what is that? Argument error? Bad value for range. So what's going on here? The problem is that custom objects can't be used in a range by default. But not all hope is lost. We just need to teach Ruby how to count. So in order to be used in a range, there are 2 requirements. First, your object has to implement this little less than, equal, greater than operator, sometimes called the spaceship operator. And that's to compare 2 objects. Secondly, you need to implement the suck method, which will return the next object in the series. Here's how we might do that. And one of the advantages of the implementation that we chose is that we can basically just delegate those 2 methods to that internal counter. So here, we want to compare our internal counter for months to the other month's internal counter. And when we want to get the successor, we will just get the successor for our internal counter, create a new month for it. And with those 2 methods now, our code from before will work. We can put them in a range, and would you look at that? March 2022, April 2022, May 2022, and so on. We've got custom objects that behave just as nicely as the built-ins. And now we're back to having delightful code. So we've seen arrays, we've seen ranges. There's some other classes in Ruby as well that all have these really nice convenience methods. Things like each, map, reduce, select, find, and a whole bunch more. These all come from a module called Enumerable. You may be familiar with it. Now I'm going to tell you a story here. One of my favorite novels is The Count of Monte Cristo. This is a tale of betrayal, revenge, and intrigue. It also looks at some deeper themes, such as human nature, fate, and free will. But I have to give you a warning. If you're going to read this, it's a long book. Like really long. So if we wanted to write some code that would deal with this book, we might decide to have each chapter be its own separate file on the file system as a performance optimization. While that works nicely, it's not pleasant to work with. Our people who want to write code to interact with the book want to think of the book as one single collection, not as a bunch of files on a server. So again, sometimes when your building blocks don't allow you to write nice code, you can build a custom object. We might create something called a composite file. This sits over a bunch of chapter files and pretends to be one file, even though under the hood it's multiple. And so we might try to use it like this. We create a composite file with all the chapters. That is now our book, Monte Cristo. And we would like to find the first line that makes a reference to Villefort, who is one of the villains of the tale. Unfortunately, we're going to get another exception. Undefined method find for composite file. And that's because custom objects are not enumerable. Again, we're going to need to teach Ruby to count using our custom object. So here's how we might do that. We might define each for the custom file, or the composite file. The implementation here doesn't really matter, but it loops through all the underlying files and yields each line. That gives us some convenience because now we can loop through the entire book one line at a time and don't have to care that it's stored as multiple files on disk. But the real magic is going to come from this next line. Right here, include enumerable. When you have each defined and you include enumerable, all of a sudden you have access to all of the goodies. You can map, you can select, you can reduce, you can find, you can do all these things. And now, that task we were trying to do earlier, it just works. Here is the first line in the book that references Villefort. And people who write this code don't need to know about the underlying implementation. They don't know that we've searched through multiple different files. This comes from the 6th chapter. It's the 6th file. The writers of this code don't know and they don't care. We're back to having code that is delightful. So enumerable is great, and there's a lot of convenience methods in there. But sometimes you want to go a little bit further. Sometimes you want to combine multiple enumerable methods together. So let's say we want to output a list, a nice numbered list where we have this little prefix in front. Here's one way that we might do that. Enumerable offers us this really nice method, each with index, that allows us to loop through an array while also at the same time keeping track of what number it is in the array. By default, it counts up from 0 because arrays, but also it gives us the ability to set our own custom start number. And so we're going to count up from 1. And this little block here will indeed output the result that we're looking for. But what if we don't want to write to standard out? We would like to capture an array because we're going to do some more work with it later on. Enumerable provides an each with index method, but when we're trying to capture an array, normally we would use map. And enumerable does not offer map with index. So are we out of luck? Well, no. Here's something that looks very similar that we can do. Array.map, and notice there is no block on the map. We're just immediately chaining another method there. And you'd think that would probably blow up. We'd get an exception. But no, it works. Exactly what we want. We now have that array of 1 first, 2 second, and so on. And it's not just map. Most of the enumerable methods, you can do this, and you can go really wild. Here, I'm doing it kind of nonsensical, but I'm doing a cycle, and again, no block, and chaining with index, again, no block. Calling select. Select is the last one, so I do give it a block, and that works. We get some sort of array back. Now, how does this work? Remember, I mentioned you call it without a block. And if you call map on an array without a block, you don't get an array back. You get something called an enumerator. Now, notice this is enumerator, not enumerable. Enumerable is the module. Enumerator here is some kind of object, some instance. So what is an enumerator? Enumerator is the glue that makes counting in Ruby so delightful. An enumerator is absolutely everywhere in our language. Remember that example in the beginning I showed, 3.times? That's an enumerator if you call it without a block. You may have seen the syntax, 5 up to 10. If you call that without a block, that is also an enumerator. And of course our friend each, 123.each without a block, that gives us an enumerator. If we do our jobs right as library, as code writers, our users often won't even be aware that enumerator is what's driving that delightfulness under the hood. But we still don't really know what an enumerator is. So today I'm going to give you 3 mental models to think about what an enumerator is, what does it do. These mental models are thinking of enumerators as a cursor, thinking of enumerator as a series generator, and thinking of enumerator as a lazy-ish kind of list. So first, enumerator as a cursor. Enumerator is not itself the collection, but you can think of it as a cursor to tell you where you are in an iteration over a collection. In this diagram here, our cursor is at the second element, but the cursor can move. So as you're iterating through, the cursor might move to 3, and then it might move to 4. Now, this cursor can move and then pause, and you can pass the whole enumerator somewhere else, and somebody else can move the cursor one more step, and again, pass the enumerator along. And so you don't have to go through all of your iteration all at once. So here's one way that we might move the cursor. There's a lot of ways to construct enumerators, and one method is this toEnum method that all objects in Ruby have. The details don't matter too much, but it will return an enumerator that traverses our array of 1, 2. And so if we want to move that cursor, first we call next on it, and we get the first item. And we could pause there, but at any point we want, we can call next again and get the second item. And then we call next again, and our cursor just kind of falls off the end. We get a stop iteration exception. And that's normal, that's expected. The second mental model I want to look at is thinking of enumerator as a series generator. Remember I talked about series being a common way that we like to control iteration, to build a set of steps that we'd like to do. And enumerators are often a way to construct fairly complex series. So here's another way that you can construct an enumerator is with this produce constructor. And here we're saying that every time we want to get a value out of the enumerator, it's going to give us a random value between 1 and 100. And so we ask our little generator, hey, give me the next value in the series. And we get 7. And then we ask it again, give me the next value in the series. And we get 51. And we could keep doing this as long as we want. In fact, this particular series is infinite. Now you might be asking yourselves, infinity? Isn't that like going to be a problem? How can we iterate through something that's infinite? Which leads us to our next mental model. A lazy-ish list. And so enumerators are, you can think of them as lists where the values that have been looked at have been evaluated, but there's a potentially infinite other values left in the list that we have not evaluated yet. And we only evaluate them if we need to look at them. And that's why we can work with seemingly infinite lists. Here's another infinite series. I'm calling the cycle method from Enumerable on an array. And cycle, if you don't give it an argument, will just repeat that array infinitely. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, forever. Now, because it's infinite, that doesn't mean that we can't use it. We can call this take method to get the first 4 elements, and only the first 4 values of our enumerator will be evaluated. There's still an infinity more, but that doesn't matter because it's lazy-ish. Now, you'll notice I keep saying ish because there's a lot of caveats around that laziness. There are variations on enumerators that are fully lazy. We don't have time to go into them today, but if you want to come up and see me after the talk and talk about lazy enumerables, I'd be more than happy to go down a whole rabbit trail there with you. So that's 3 mental models of what enumerators are. And enumerators have 2 important methods that are defined on them that are available on all enumerators. We've looked at the first one already, this next method. This steps us to the next value in our series. It forces us to evaluate the next value in our lazy list. It moves the cursor. Whatever metaphor is working for you today, that's what next does. If you've read the book Design Patterns by the Gang of Four, you may recognize this as a form of the external iterator pattern. There's also a second method on enumerators that is really helpful. Our friend each. Each will execute the given block for every item in the collection or the series. And this is another pattern from the Design Patterns book. It is the internal iteration pattern. Beyond just the pattern, though, because this is Ruby, having each defined on it also gives us access to the enumerable module. Remember I said enumerable, the module, is different from enumerator, the object. And so here, enumerator, the object, because it includes enumerable, the module, has access to all of the goodies from enumerable. So you can map, you can filter, you can reduce, you can find. All of those you can do on an enumerator. So why might you want to use an enumerator? Well, I mentioned earlier that we often like to have series to control our iteration, to generate a set of steps that we want to do. And so enumerators can generate fairly complex and custom series, something more than you could do with just a range. Because a range is just going to go in order. 1, 2, 3, 4, A, B, C, D, January 1st, January 2nd, January 3rd. But as we saw, you can have a series where every value is random. You can have a series derived from an existing collection. You can have a series that generates the Fibonacci pattern. Really, it's up to you. And it could be finite, it could be infinite. You can create pretty much any custom series and then have that run your iteration. Secondly, it gives us control over our iteration. That's because you can move next to the next item in the series and then pause and potentially even hand off the whole iteration to somebody else to keep going on through the work. You don't have to go through all of it at once. And finally, one of my favorites is that you can bake in an iteration strategy. What does that mean? Let's look at that in more detail. Let's take a look at something that has multiple different valid traversals. So if you remember our composite book from earlier, where we're trying to show a file that pretends to be a single file, but it's actually multiple under the hood. And we included enumerable. We had an each method that went over each line. And our users love this class, but they tell us that they don't always want to iterate over each line. Sometimes they want to iterate over each word. The problem is we can't define 2 methods, both called each, in our class. They're going to conflict. And when you include the enumerable module, it's only going to allow you to access its helpers through the each method. So we're stuck. We're going to have to pick one to be sort of the blessed traversal, and the other one is just out of luck. Or are we? We can use enumerators to solve this problem. So first, we're going to name each traversal with a nice name. So we have each line and each word. And then we're going to do something fancy. We have down below just our regular looping logic, but we have a condition at the top of the line that says, if you don't give me a block, instead of doing the iteration, return an enumerator and use the looping logic below as the strategy for how this enumerator will traverse the collection. So we haven't actually traversed it, but we've baked in the strategy into this enumerator object that toEnum returns. This pattern of saying, if you don't give me a block, return an enumerator, is exactly what powered the magic that we saw in the enumerable module, when you call map without a block, when you call 3.times without a block. They're doing exactly the same thing here. So we're following a classic pattern for our own custom collection. And when you do that, we now have baked-in traversals that our users can choose. So if you call montecristo.eachline, you get back an enumerator object that knows it's going to iterate one line at a time. But if you call montecristo.eachword, you now get an enumerator that has baked in the fact that it is iterating one word at a time. Now, we could decide to do our iteration right now, but we could also just pass this along to somebody else. Maybe something else that just is going to respond to each. So we might even pass this into, let's say, a HTML view that just wants to iterate over everything and print out a giant list. I don't know why you'd want to print out every word, but that is a thing you could do. And what's really nice is remember that enumerator objects include the enumerable module. So all of the goodies that you're used to having are available on these two traversals that are baked in. That allows us to do things like that, where we say, for every line in Monte Cristo, find the first line that matches this particular pattern. Or we might say we want to apply a function to every word in the book. Now that's a lot of words, but you could do that. And for users of our code, they don't need to know about enumerators. They don't want to know about underlying files. All they need to know is that there are two ways to traverse. Choose your traversal strategy, and then you can just call the methods you know and love from Enumerable that you are used to, that you are comfortable with, and all of the rest of that complexity is hidden away. And now we're back to having code that is delightful. So here are a few tips to write delightful iterative code in Ruby. First of all, if your underlying building blocks are clunky to work with, if they're not representing the actual work that you're trying to do, you might want to introduce some domain objects, some custom objects that give you the real building blocks to do the work you need to do. Once you do that, though, you might need to teach Ruby to count. You might need to do things like implement the interface for range or for enumerable, so that your custom objects are just as delightful to work with as the primitives that Ruby ships with. Finally, you might need to glue it all together using enumerator. This could be packaging or pre-packaging some traversals for people so they can just use them and call their iterator methods on there. It might be to create some really custom series, or maybe even to allow you to have a really fine-tuned control over the iteration that happens. So thank you for coming to this talk. I will not be doing questions up on the stage here, but I will be standing off to the side. So if you'd like to come and talk to me about going deeper or any questions that you have, I'd be more than happy to chat with you. My name is Joël Quenneville. I work at Thoughtbot, and you can find me on Twitter at JoelKen, assuming Twitter still exists next week. Thank you for coming to my talk.